Welcome. Today I want us to look at the sine and cosine roots. And please don't forget to subscribe, like and share this channel. It is Udum Maths. Okay, so let's solve this triangle. When you talk of the sine and cosine rule, we are only looking at those the sides and the angles of a triangle. Okay, so when you hear sine rule or cosine rule, please don't panic. It is just if I don't want to okay, let me say it's nothing as usual. It's nothing. Okay, now let's try to deduce from this triangle the sine rule. The sine rule. So let me put it here. The sine rule. Sine rule. So just here. Now, sine deals with angles when then the sides. So for the sine rule, if I take this beta faces this side BC, which is B. Angle beta faces side BC, which is B. So sine of this angle over the side B should be equal to sine of this angle alpha over the side AC, which is C. So sine alpha over C, because alpha faces C. And this is also equal to sine of theta over the side AB, which is A. So sine theta over A. And this is all about sine rule. In some books, you see B over sine beta equals C over sine alpha equals A over sine theta. And that is also correct. So the two are correct. Please, we are not going to use the 3 in a question, just that we'll use either this one, this and this, or this and this, or this and this one in solving a question. Okay. So let's go to that of the cosine rule, then we'll look at an example. Okay. Now when we started the sine rule, we said the sine rule deals with the side and angles. So the same thing applies to the cosine rule, also deals with sides and angles. So now let's see. We are starting from this side AB to get the remaining sides. Okay. So for you to get side AB, look at it. We have ABC. ABC. So pay attention to the first one. From when I do the first one, you can do the second and then the third. That is B and then the C. Okay. So A squared, that is looking for side AB. So A squared is equal to B squared plus C squared. So B squared plus C squared. Then minus 2 times BC minus 2 times BC. So minus 2 BC. Sorry. So 2 BC. Then cos. Please, A faces theta. So cos theta. A faces the side theta. The angle theta, sorry. So cos theta. Now let's take that of B. So B squared is also equal to A squared plus C squared minus 2AC. So 2AC. Then cos. Now B faces which of the angles? Beta. So cos beta. Then C squared is also, like I said, after doing the first, you should be able to do the third and then the second and the third. So C squared, I hope you've paused, and then after you are going to get the same thing as I am going to get. So C squared is also A squared plus B squared minus 2AB cos. C faces alpha, so cos alpha. So that is that. Now let's look at this. Solve the triangle ABC below. So this is triangle ABC. Triangle ABC. Okay. Given this, we need to just subtract the sum of this from 180 to get this one. So we can say that 48 plus 57 plus beta should be equal to 180 degrees. So it means that beta is equal to 180 minus 105 degrees, and then beta subsequently becomes 75 degrees. Okay, now let's look at so we've had beta to 75 degrees. Okay, so we can also go by the sine rule and the sine rule or the cosine rule to get beta other than this one. Okay, so let's look at finding A and then C. Okay, so A faces 48, angle 48, and C faces angle 57. Let me use this one and this one with this one. So 47 over sine beta, which is 75, so sine 75 is equal to A over sine 48. Okay, so this one needs cross multiplication. So A sine 75 is equal to 47 sine 48 degrees. Okay, so here we divide both sides by sine 75. So A becomes, okay, let me do it straight. So here sine 75 here, and then sine 75 also on this side. So A is going to be 47 sine 48 over sine 75. Please here use calculator. Don't just say sine, then use calculator straight away. Okay, so this is going to give us 36.159 degrees, and we can say that A is approximately 36.2 degrees. So that is that. Now we need to look at finding the C. So 47 over sine 75 should be equal to C over sine 57. Okay, then this needs cross multiplication. So C sine 75, that is this and this one, should be equal to this and this one, 47 sine 57 degrees. Okay, now we need to divide both sides by sine 75. So C is equal to, or sine 75 over sine 75. So C is equal to 47 sine 57 over sine 75 degrees. Okay, so C becomes 40.8 degrees, and that C is approximately equal to 41 units. So here there is no degree sign here. There is no degree sign here. Okay, so that is 47 sine 48. After going through all these things, this is going to give us 36.159, and then that is equal to approximately equal to 36.2 units. And then you can say 36 units. Okay. Now let's look at one more example. That is triangle ABC is such that side AC or line AC is equal to 9.9 centimeters. And then side BC or line BC is equal to 8.2, and angle ACB is equal to 25 degrees. So find the side AB. So what we need to do is to draw the triangle. So let me draw the triangle here. Okay. So line, this is A, B, and then C. So line AC, this side is 9.9 centimeters, and then the side BC 8.2, so 8.2 centimeters, and then we are told to find the side, and also angle ACB. Angle ACB is 25 degrees, so ACB 25 degrees. Okay, so now let me put X here. So let me start with the I'm going to look at it by the cosine rule, which will best, because we have two sides and one angle. So side angle, or side angle side gives that. Or the best rule to use is the cosine rule. Maybe after getting this one, you can use the sine rule to get other angles. We let the side AB equals x, so it means that x squared is equal to, into brackets, 9.9 squared plus 8.2 squared minus 2 into brackets 9.9 times 8.2 cos, and the side AB, which is x faces 25, so cos 25 degrees. Okay, so x squared becomes 98.01, then 8.8 squared, so that is also 67.24 minus this one times 2, 162.36 cos 25 degrees. Okay, so 98.01 plus 67.25 is 165.25. Okay, then minus, and this is also going to give us 147.148. Okay, so after subtracting this, you are going to get or we are getting 18.1. Okay, so this is x squared. So when you put square root on both sides, x becomes 4.25. Okay, so therefore the side AB is equal to 4.25 centimeters. Okay, now let's look at one more example. The three sides of a triangle are 4 centimeters, 6 centimeters, and 8 centimeters. Find the largest angle correct to the nearest degree. Please, this is a very beautiful question. And what you must do is to draw the triangle so that will help you solve the question. And let's look at this. Where we have the 8 centimeters, that corresponds to the largest angle because that is the wider place. So that corresponds to the largest angle. So let me draw it. So let me assume this is the largest angle, which is theta, and this side is 8 centimeters. Then the rest, the smallest of all will be for that, so that is 4 centimeters, and this one is 6 centimeters. Okay, so we need the cosine rule to help us solve this example. Okay, now we want the angle that faces 8. So then it means we can use the side 8. So 8 squared is equal to 4 squared plus 6 squared minus 2 into brackets 4 times 6 cos theta, because 8 faces theta. Okay, so 8 squared is 64 equals 4 squared is 16 plus 6 squared is 36 minus 4 6 is 24. 24 times 2 is 48. So minus 48, then cos theta. Okay, so 64 equals, this is going to give me 52. So 52 minus 48 cos theta. This is 6 plus 36 is 42 plus 10 is 52. Okay, so I am going to send this one here, then bring this one in. So that is all I can say. That okay, I am going to bring this one, so that is 64 minus 52 equals negative 48 cos theta. Okay, now this is going to give me 12. This is 12 equals negative 48 cos theta. Then we need to divide both sides by negative 48. So this is, we divide both sides by negative 48, and then here to negative 48. So cos theta becomes this is into itself 1, here 4. So that is negative 1 over 4. And you know cos can never be negative. So it means that theta is equal to cos inverse of negative quarter, which is going to be 104.5 or 0.47. So we can say 5 degrees. So to the nearest degrees, we can say that theta is equal to 105 degrees. Okay, please don't forget to subscribe, like and share this channel. Thanks for watching. The name has always been Odu Maths. Bye.